Hi, today we are going to apply our algebra skills to solve for specific variables in chemistry formulas. Our goals for today are to review properties of algebra and then apply our algebra rules to chemistry formulas. The big rule in algebra is that whatever we do to one side of the equal sign, we must do to the other side of the equal sign. The addition property of equality states that whatever we add to one side of the equal sign, we must add to the other side of the equal sign. Here we have x minus 6 is equal to 10. Our goal is always to get the x on one side of the equal sign all by itself, which also means that we want the coefficient, the number in front of x, to be 1. In order to do that here, we would have to add a 6 to the left side of the equal sign. Therefore, we will add a 6 to the right side of the equal sign. So now we have negative 6 plus 6, and we get the x all by itself on the left side. Then our result will be x is equal to 16. The subtraction property of equality states that whatever we subtract from one side of the equal sign, we must subtract from the other side of the equal sign. If we have x plus 12 is equal to 19, then we must subtract a 12 from the left side, therefore subtract a 12 from the right side to isolate the x. Now we have x plus 12 minus 12 on the left side. The 12s will cancel out, and we will get x is equal to 7. The multiplication property of equality states that whatever we multiply to one side of the equal sign, we must multiply to the other side of the equal sign. Here we have x divided by 2 is equal to 14. Since we are dividing x by 2, to get x by itself, we would need to multiply the left side by 2. Therefore, multiply the right side by 2. Then we would have 2 divided by 2, which is 1. So we just have x on the left side and then 28 on the right side. So x is equal to 28. And lastly, we have the division property of equality. Whatever we divide from one side of the equal sign, we must divide from the other side of the equal sign. If we have 3x is equal to 15, here we have 3x is equal to 15. In algebra, when we have a number right next to a variable, we assume that we are doing the operation of multiplication there. Therefore, to isolate the variable or get the variable to have a coefficient of 1, we need to divide the left side by 3. Therefore, we need to divide the right side by 3 as well. Now we will have 3 divided by 3, which is 1. So we've isolated our variable. We have our variable to have a coefficient of 1. And then on the right side, we will get 15 divided by 3 is 5. So x is equal to 5. The problems that we have done up until now, we call one-step equations. But most of the time in algebra, we have multi-step equations. We have to think, what are we doing to x? Here we are multiplying x by 2, and then we are adding 5. We have to follow our order of operations. When we solve algebra equations, we undo the operations we did in reverse order. So remember that we multiplied by 2 and then added 5. Therefore, to undo or to solve, we are going to subtract 5 and then divide by 2. So first, we'll subtract a 5 from both sides of the equation, and then that will give us 2x is equal to 14. And then we divide both sides by 2, and we get x is equal to 7. Let's do a few more multi-step algebra equations. Here we have x divided by 5 minus 4 is equal to 7. We would want to add a 4 to both sides of the equation, and then we would get x over 5 is equal to 11. And then to get the x by itself, we would want to multiply both sides by 5, which would give us x is equal to 55. One thing to keep in mind is if we see something like x over 5, that is equal to 1/5 x. If we have something like 2x over 3, that's equal to 2/3 x. We could just see the 2 over 3 as a coefficient in front of the x. That might help us with some of our calculations down the road. Let's say we have 3/4 x minus 3 is equal to 12. We would first want to add a 3 to both sides of the equation. And then we would have 3/4 x is equal to 15. Now keep in mind, we want our coefficient in front of the x to be 1. So one way that we can accomplish that is to multiply by the reciprocal of 3/4. When we multiply by the reciprocal of 3/4, we'll multiply both sides of the equation by 4/3. So on the left side, we'll just get 1, so we'll just have x. And on the right side, we'll have 15 times 4/3. Now there's two ways that you can do this. One way is we can multiply 15 times 4 and get 60 divided by 3, which would be 20. So we would get x is equal to 20. Another approach is we could divide 15 divided by 3, so we could simplify our fraction before we multiply by the 4. So then we would have 5 times 4, which would give us x is equal to 20. I prefer this second way just because we get easier numbers to work with. And so I always choose to simplify my fractions before I multiply them together, but either way works. Now pause the video and try these few practice problems. So you can check your answers for number 1 and number 2. And then check your answers for number 3 and 4. In algebra, sometimes you'll see problems where it says solving literal equations. And what this means is you have several variables and you need to solve for one of them. So here we have b is equal to x plus y over 5, and we want to solve for y. So we have to look and say, what are we doing to y? Well, we are adding x and dividing by 5. So we want to do the opposite operation in reverse order. So here, to get that y by itself, we want to multiply both sides by 5. And then on the right side, 5 divided by 5 would just be 1. So then we'll have 5b is equal to x plus y. Again, we want to get that y by itself, so we can subtract an x from both sides of the equal sign. So then we would have 5b minus x is equal to y. And most of the time we want that y to be on the left side. So we have y equals 5b minus x, and that would be solving for y. Here we have x is equal to 7 and then parentheses a minus b, and we want to solve for a. So we have 7, which is a factor, and then this a minus b is a factor because it's in the parentheses. So here we could divide both sides by 7. So then we would have x over 7 is equal to a minus b. To isolate that a, we need to add a b to both sides of the equation. Then we would have x over 7 plus b is equal to a. And then we could put that a on the left side, so a is equal to x over 7 plus b. And that would be our equation solved for a. Now let's say we have the same equation, but we want to solve for b. So again, we would divide both sides by 7. Then we would have x over 7 is equal to a minus b. And then we want our b to be positive, so we could add a b to both sides of the equation. So the b's would cancel out on the right side, and we would have x over 7 plus b is equal to a. So then to get the b by itself, we would need to subtract the x minus 7 from both sides of the equal sign. Then we would have just b on the left side is equal to a minus x minus 7. And that would be our equation solved for b. Now let's look at some formulas that you'll be seeing in your chemistry class. This is the density formula, where density is equal to mass over volume. And if we want to solve for mass, since we are dividing by the volume, we would want to multiply both sides by volume, and we would get mass is equal to density times volume. Let's say we have that density formula again, but now we want to solve for the volume. The first thing we would need to do is to multiply both sides by the volume so we can get the variable that we are looking for in the numerator. And then we would have volume times density equals mass, and we could divide both sides of the equal sign by density. And then we would have volume is equal to mass over density. So that would be the density formula solved for volume. Here we have Boyle's law, and that is pressure 1 times volume 1 is equal to pressure 2 times volume 2. So we want to solve for pressure 2. So here we would just need to divide both sides by volume 2. Then our volume 2's divide out. So we would just have pressure 2 is equal to pressure 1, volume 1 over volume 2. It is a little bit more work when we are solving for a variable in the denominator, because we need to make that step to get the variable into the numerator. So here we will want to multiply both sides of the equation by 2t, and the 2t's on the right side will divide out. We'll have 2t times v1 over t1 is equal to v2. And then we need to multiply the numerator by t1 and divide by v1 on both sides of the equation. Now our V1s will divide out, our T1s will divide out, and we are left with T2 is equal to V2 times T1 all over V1. So there's a nice little thing in math called cross multiplication, which is actually just a shortcut way of applying our algebra rules. And if we have something like A over B is equal to C over D, we can cross multiply to get AD is equal to BC. Now I want you to realize that all we're really doing here is we're just multiplying both sides of the equal sign by BD. And so that will divide out the B on the left side and the D on the right side. And so we get that AD is equal to BC. But knowing how to cross multiply really does come in handy when you are working with your chemistry formulas, because for something like this, if we're solving for V2, then I can say, well, I can just cross multiply and I'll go ahead and get my V2 on the left side, and I'll have V2 is equal to V1 times T2 all over T1, and then I would have solved for V2 and be done at that point. Here we have the specific heat formula, where Q is the amount of heat, M is the mass, C is the specific heat, and we have delta T, so change in temperature. So if we want to solve for C, the specific heat, we would divide by mass and the change in temperature on both sides of the equal sign. So that would give us C is equal to Q over M, and then change in temperature, or delta T. We'll do one more specific heat problem. Here, instead of having delta T, we have T2 minus T1. Now remember, we have M, C, and what is inside the parenthesis are all factors. They're all multiplied together. So if we want to isolate that T2, then we could divide by M and C on both sides of the equal sign. Then we will have Q over MC is equal to T2 minus T1. Then we can add a T1 to both sides of the equal sign. On the right side, the minus T1 and plus T1 would cancel out, leaving us with T2 is equal to Q over M times C plus T1. So I hope this helps you kind of get through some of the math in your chemistry. There's some practice problems, and I've worked out the solutions so you can check your work, and I wish you the best of luck in your chemistry class.